Masuli here.
Hi guys, Dimo from Masuli.
So far,
Let me explain what happened previous
Okay.
session.
okay.
I remember that previous session we have seen the HTTPS document, yes? And
Okay.
this session we are going to refactor our code to HTTPS, yes, connections.
No, not HTTPS. No.
Just HTTP.
Yes, HTTPS is another protocol on itself. It's another topic.
So we are going to use a whole document or no? We are going to write it ourselves.
We are going to look at the document, the RFC,
Mm-hmm.
the explanation of the HTTP protocol, and we are going to replicate it on our in our code. So as you said, we tested, with this dummy code, 40 lines of code, and each time this socket server returned a static HTML just to prove that this HTTP server is working, and this Chrome browser as an HTTP client understands what it says. So an HTTP client can only talk to an HTTP server, and both of them should follow the rules of the HTTP protocol written on that RFC that we saw in the last session. This session, we are going to, as you said, we are going to refactor our code, because here we are using a server that we've written ourselves, and it is not using any noun protocol out there. It is something that we made ourselves. So for example, we said that we are taking \n as the delimiter, and first the command will come, then and \n, then for example the body and all that, and we are going to refactor it so that other HTTP clients, like other standard HTTP clients like Chrome, be able to work, connect to our server. Because now only this customer can connect to the server that we've written, because only this customer, the connector, knows how to talk with the server. But and if we want to let the others to be able to connect to our server, we have to publish some kind of document like the HTTP that we've seen, and explain how the communication, how the messages works. For example, the client has to send something, then the server will take it as the command, and if it doesn't see, for example, the command at the beginning, it will return something to the other side. So this ifs and the things will be the rules of the protocol, and we have to publish it. And but because everybody uses HTTP, we will also use HTTP, and we are going to refactor it. Actually,
we are going to follow those standards.
Yes, the standards in the HTTP. So let me open that protocol again, the HTTP RFC. I think it's 2616. This is the document of HTTP, and I remember we had section 5 and 6 about request and response. The section 5 was about request, and section 6 was about the response. So here we know that the request has a request line ended with CRLF, and the CRLF is 2 consecutive bytes characters. CR is carriage character and is number 13, and line feed LF is 10, character 10, byte 10, and then comes the headers, delimitered by CRLF again. Then if we see another CRLF after the last CRLF, we indicate it as the end of the headers. So no more headers. We take it as, okay, no more headers is in the incoming sequence of bytes from the other side. Then we take the rest until the end of the sequence as the message body. And we will understand from a special header, from the content length, that how much this message body will be, for example, in bytes.
How many characters?
How many bytes, not characters. There is no character here. Everything is byte. And so we are going to refactor this. This is a server. Let's rename it to HTTP server. HTTP server. And it's renaming. Okay. And if we go inside, we have something here. We have request. This request will be, of course, HTTP request. And let's rename all of them. No, we can leave it as is. And also response, let's rename it to HTTP response. And so an HTTP request here, there is nothing named command or parameters in the HTTP request. We have method, so we should use the same terminology. Method, request URI. The HTTP version is not important here. We are going to ignore that. Then the headers, which will be a map of key value pairs.
We are going to write hold on.
Yes. And then also we have to get the query strings, but maybe later. So method, this will be method, HTTP method, not the command. These parameters will be headers. Again, headers is a map, string key value pairs. The body here, we are not going to, also we have a body, yes? This message body is actually the body, but let's not return it as string. We can return it as input stream, as the sequence of bytes, but because maybe it's, if you want, maybe it's a file, incoming file from the other side. You know, we are not going to always convert it to a string. For the sake of this application, we can leave it as a string, because for the moment we are just, you know, returning string. We are taking the body, the whole body, as a string, and for example converting it to a JSON. But if we want to use a, you know, a general HTTP server for every purpose, we have to change it to string, input string. The body will be input string. So let's leave it as body, but we will come back to that later. And the HTTP response, of course, is again, there is no method in the response. The response will be status, of course. We'll have, let me show you. In the section 6, we have HTTP response. The response will have status line. Status line is HTTP version space status code space reason phrase. This reason phrase is the explanation of the status code. So we will have a status code and then a bunch of headers, then the message body. So status.
So actually we are going to make that constructor, yes? To
what?
No, that's a kind of constructor to make that
this
document.
Yes. Headers
to receive those
no.
values which we need.
This is the responsibility of HTTP server to take out those pieces
Exactly,
and put
yes.
it to HTTP request. Here you can see that it first extracts the bytes and then constructs via the constructor an object, the HTTP request object. And from there, you know, the rest of the system doesn't have to worry about what is this request, for example, where the destination, the origin, you know. All the rest of the system has to worry about is, okay, this is an HTTP request. I have to return an HTTP response. And then the server is responsible to serialize it and send it to the other side. So the HTTP response will have a status code, headers, and body, and of course we can have query strings. I'll explain later what is a query string. So now we have the server socket. Nothing. This is the same here. We will have a server socket, of course, listening on some port. And when we accept an incoming connection, then we get the input stream and output stream. Again, nothing changes here. Then we get the byte, and we are actually command is seen, new line has seen. Let's get rid of all these. Let's get rid of them. Also these. We have the message so far. I'm going to use this message so far here. So let's say message so far. I'm going to concatenate the byte dot to char to the message so far, and then I'm going to say if message so far ends with \r\n carriage line fit number 13 number 10 byte.
That wasn't two of them.
No. I'm
Two backslash.
I know because here in the test server, this was an example, just as an example. We were just taking the whole. Of course, we can do that. Actually,
that was our test.
Actually, that's a better idea. First, to take the whole, because here, first we were taking the whole headers and the first line, and after that, we were actually breaking from this while loop, and then the rest of the bytes, we knew that the rest of the bytes is the body. Actually, that's a better idea, yes. So ends with 2, when it ends with 2 \r\ends, it means that we are here. Yes, we are here. We've seen the first line, we've seen the rest of the headers, maybe 10 headers, 20 headers. Then we are at the beginning of the message body, if there is any. That's a better idea. Okay, when we see this, we break from the character. So this message so far will be because this is a request and headers. Yes. And now if we split this string with \r and \n, it will be actually, let's get the first line. Val, first line means request line. Yes, we have request line. Request line is the first line until the first CRLF. So request line equals request and headers dot substring before first \r\n, not the \r and \n itself. Substring before.
Whatever comes.
Yes. So this will be the request line. Yes. Then if we substring after that, if we say request and headers dot substring after the first \r and \n, it will be the headers until the end. So if we split it with \r\ns, we will have the headers. This will be headers, and then we have to actually substring them. Substring them. Take the colon, because each header, as you can see, headers are. Let me show you: general header, request header, entity header. So a general header is, if I want to show you, the headers come like this, then a colon, and then the value of the header. I'm not seeing it here. It is actually somewhere there, that each header will be the key, then a colon, then a value. So these are the headers.
So here in the headers,
actually we are to take the pieces out from the headers and the request line.
There is a text, something like that, for example. Then \n, then \r. So we will forget whatever comes before them. Yes.
Something like
Repeat
that.
after them.
No.
Whatever writes after them.
No, it is something like this. It is something like this. The headers are something like this. For example, content.
I mean this line substring after.
You mean
first
the headers?
of all, yes. First of all, you will cut whatever comes after \r and \n.
Yeah, yes, because the first after, because the headers comes after the first \r and \n.
And then what will happen?
Because the first \r and \n is the request line.
Yes.
And then.
But you split what then?
Then we take the whole string after the \r and \n, and because we know that the string that comes after this is it has lines ended with \r and \n itself, because the headers, as you can see here, headers, each header ends with CRLF, each header.
My question is that what will happen after a split?
After a split is a function on a string.
You split what? There is for example,
let me show you. We have A, comma B, comma C, comma D.
Then \r.
If we split it with comma, we get
on A,
A,
B,
B, C, D. It will return a list of a string for us. It's a function on a string that will split on the delimiter that we are giving it. For example, if we have something like backslash r backslash n,
so it
backslash
will
r backslash n, and we say, please, we know that we have
substring after backslash r and backslash n.
This is the first part. This is the first part.
Okay, we will have B.
No. Just let me show you actually the actual.
Write in a statement.
Okay,
for example, hello backslash r backslash
we
n.
have get. I'm writing an actual HTTP request. Get ABC, for example, image. Sorry, for example, like something like this. First, this is the request line. First comes the HTTP method, then the HTTP URI, then comes the space between them, then the version HTTP/1.1, then backslash r backslash n. Then comes, for example, the header content type is, for example, I don't know, JSON. Then if there is another header backslash r backslash n, again delimited by backslash r. For example, another one could be content length is, for example, 120 bytes. Then if there is another header, we have backslash r backslash n. A is, for example, 10, some special. Then 2 consecutive backslash r backslash n's means the end of the headers. Then comes the message body, whatever it is.
So here in substring, what will happen in substring?
So when we take
in headers,
okay. So until here, we've stored into the request and headers. Request and headers ends with 2 consecutive backslash r backslash n's. So when we see 2 backslash r and backslash n, we break from the while loop. So now we have this piece of a string.
10. We have it up to 10.
In here. Okay. No, up to this backslash n, not 10.
Okay.
When it ends with,
yes,
we break.
Okay.
Then we substring before backslash, first backslash. So we substring until here.
Okay.
We take it and store it in the request line.
Okay.
Again, we tell substring after first backslash r backslash n. So from here
up to JSON.
We substring until here. Here.
But you say after the first backslash r and backslash n.
This is the
first.
This is the
that
first.
is the first.
This is the first.
So up to the end.
Up to the end. The end is here actually.
Okay.
Because we've not read the rest from this string.
Yes.
And then from this we say split the content. When you see backslash r and backslash n inside it, split them and put them into a list of string and bring it.
So we have content type JSON in one.
Yes, content type JSON in one of the
strings. Then content links. And
this will be list of
I've got it.
String, and this is a string actually. This is a string. This is a list of a string. Okay, so let's just be there actually for maybe we have some other questions. So the request line, if we go tackle them one by one, the request line is, as it explained here, method space request URI space HTTP version. So if we say request line, so we have to take the method out, method equals, we know that in the request line, if we split it again with a space, because it has spaces in between. If we split it with a space, the first one will be the HTTP method. Yes, the first one is here.
Yes, method. Space line. Yes.
We could do something.
That is get.
Yes, we could do something like this: substring before first space. That is also the method again. Then we have, after the first space until the second space, we have the request URI, actually the resource URL or whatever. That indicates the resource that the request tries to access. So for that, we can, for example, say val request URI equals request line dot. We can substring after the first space, not before, until substring before a space. Yes, because when we substring after the first space, we get this part. Then if we substring before space, we get
Image.
this part. Yes, backslash image. Then we don't need the HTTP version actually. We will ignore the rest. We don't need this HTTP version.
Okay.
So this is Recourse URI. We have two pieces. Then the headers. Actually, for the headers, because we know there are list of strings and each string it has a colon in between, we can say dot. I'm going to use the functions we used before for like for each map and all that. I'm going to map because I know it is a string like this. It is one, you know, this, then it is this, then it will be a:10. Then I can say it dot substring before colon will be key, then the value will be after colon. Then I'm going to actually return from this map. Let's return key. I don't want to use the functions like key to value, and actually maybe it will be too much, and then convert it to map. We can do like something like that, but actually let's create a pair here. Pair is an object
like a map.
No, pair is a simple object, takes two things.
Just look like a map. Key value.
No, just a key, just a simple class. If I want to show you, pair is a simple class, has first and second, just that. Very simple.
No more, no less.
Yes. So I'm returning a pair where the first is key, the second is value from each iteration, you know. I iterate over all the headers, split them into the first part, second part, delimited by the colon as key value, then return the pair. Now we will have pairs. This will be this list of pair. Yes?
Yes.
List of pair, but it is...
Because maybe map is, headers is a string, cannot accept.
No, the pair of string and string. String and a string, I think. Yes. We are having a list of pairs.
Pair of
a string and a string. And actually we will see, I'll explain this angle tags later, the generics later. But so this map actually is feeding each item to this function, and then receives something back, as we said before, and stores in a list and returns that list. Then we can actually say, please convert this list of pairs to a map. Now it will be a map of string and string. So I converted a list of pairs to a map. There is a function for that, and I call it toMap. We'll convert it. Now we have these are headers, actually headers. We have the headers. This is the header string. And yes. Okay. Now we have the method, the Recourse URI, and the headers, and also the rest of the incoming stream, which is sitting there waiting for us to read, and we have not read it yet, is the message body. So we can create a request. We can say method, and then we have the headers. Actually, the headers will be headers. Then the body will be, it is actually asking for string. I don't know if we should pass string at this point or convert it to string. Let's convert it to string. Actually, for converting to string, we can say in stream dot read all bytes to the end. If we say read all bytes, it will read until it sees -1 in the stream, which indicates the end of the stream. And then we convert it to string with the char set of charsets.utf8. So this is like, this one line here is actually like putting this in stream again in a while loop, reading it line by one, byte by byte, convert it to the char, append it to some string, and then return it. Actually, we are telling read all the bytes from here, from this point in the stream to the end, from here actually to the end. Then it will be a byte array. Then try to create a string out of this byte array. And when you are actually converting a byte of array into string, you have to tell it how to treat the content. For example, we say you can take, if we say ASCII here, ASCII, US ASCII, it will take each byte as a string in a table. So we have an ASCII table here. Let me show you ASCII table. If I want to show you that, this is the ASCII table, and these are the bytes until from 0 until 1 to 7. For example, if it sees ASCII the byte 48, it will take as 0. If it sees, for example, byte 90, it will take it as uppercase Z. But if we, for example, say here, I have a byte of an array, when you are going to convert it to string, treat it as a sequence of UTF-8 bytes. It may take 2 consecutive bytes and check it in the other table, which has, bigger table and takes 2 bytes at a time. For example, if you have Persian characters in the body here, each character in the Persian char set takes 2 bytes, 2 consecutive bytes. You cannot take each byte one by one and treat it as a character. Okay, so we converted to string. Now we have an HTTP request, and we actually need an HTTP response. An HTTP response has a status and a body. Nothing has been changed there. Then this interface, we have new connection has been made. Let's convert this name to new incoming request. And, or for example, handle request. It receives an HTTP request, returns an HTTP response. So let's just read up this. Okay. Now here we have actually the terminology. No, let's notify me on new request, for example. We are asking the server to notify us when new request comes. It will pass us the HTTP request. It will ask us an HTTP response. So each HTTP request has body, headers, and method. So we are going to actually, it has something else that we've forgotten, and that is Recourse URI. The Recourse URI, we've not used it yet. So it has also val request URI of type string, and here we have to also pass it here, request URI. And when we are going to handle the request, we are going to actually, there is no command here. We are going to, based on the request URI, based on the incoming request URI, we are going to know that, okay, the other side is asking for this information, or is asking to, for example, is posting something, some data on this URI. So this URI will be, we will take this request URI, and let's say that the other side will send get post list place order, for example, something like this. The other side will say localhost, then port. Then it will say get product list. So this, or it can, for example, send other things. Get product list, only vegetables, maybe, for example. Then in the server side, we will receive this from this / as the request URI, and we have to actually decide what to do. Decide what is the request of the client on the other side. So the request URI, if it is get product list, let's say, and also from now on the method matters actually. this method here.
Mhm.
Maybe the client is doing a post.
Mhm.
Maybe it's doing a get, because as you remember, we have these methods: options, get, head, post, put, delete, trace, connect, and other things. And this will mean something, you know, between the client and the server. So the server will say that if you want to create a product, please send a post to this URI and send a JSON with these key value pairs in the body. So the Recourse URI get product list, actually it will have a backslash from now on, because it's a Recourse URI. And also the place order will have a backslash, and yes. So command, so the response, now we have to, when we are sending a response, let's see what a response is made of. And status code, headers, and the body. Yes. Let's first actually create a response for get product list. So get product list, when we are going to return the response, we are going to return 200 as the success. We as the server is going to tell the other side, you asked us for the product list. Oh, okay, this is okay. 200. Here the product list. So if I want to show you the response part here, has the status line. The status line will be status code,
Space.
HTTP version, status code, and reason phrase. So status code, and then the headers. We don't have any headers. We are not sending any headers as a response to this get product list. And as a body, we are going to return the response. Also, for this one, no command, place order. Let's actually, as a server, decide that we will return 201. 201 means created. Here, if we see 201 means created, the reason phrase is created. Actually, this is protocol. You know, we are like negotiating with this client. We can return 202, 203. If we are going to return 202, then the client has to know that the server will return 202 as a meaning of success for this specific request that I'm issuing. So 201, then I'm not going to return any headers. And for example, as the body, let's send this string again. And if the response, if the Recourse URI is something that we are not recognizing, let's return 404 as not found. And no need for any body actually, because 404 actually is not found, and I'm going to use it here as well. We can return something else, 401, 402, but we, you know, it's better to use, to actually get to use the most appropriate ones for the situation that we have in hand. Maybe if we return 406 as not acceptable, we are actually going to tell something to the client. It is not acceptable. There is something like this that you are asking, but it is not acceptable at the moment. We can send 406 to the other side. And then the other side has to decide what to do from there. Okay, so I return HTTP response. Then the server receives this response. After, yes, it calls handle request, passes the request, receives the response. Then it has to send the response to the other side. So for sending the response, it has to send it like this, in this fashion, actually. So first it returns the, let's see, a correct HTTP response has the first line is the status line. The status line has HTTP version, space status code, space reason phrase. So let's say val response status line will be actually HTTP version. Yes, first comes HTTP version, which is always HTTP 1.1 space, then status code. The status code is inside this response. Sorry. Response dot status, then space, Then comes the reason phrase. Actually, for a reason phrase, we have to have this map and convert it to this string here. So I don't know what will happen if we don't send the reason phrase. Let's send this as the reason phrase. Then to /r and /ns. Sorry, one. CRLF /r and /n. Then the headers, delimited by /r. For that, we can say val request headers equals response headers. Response headers equals response dot headers dot. We have a special function again, join to string. We can say because headers is a map, we can first convert it to list. Yes, to list of pairs again. The list of pairs. Then this list can be joined to string. I'm going to convert this list to string, and it will pass each item in this list to this join to string, and I will say it. I'm not going to change it. I'm going to create a string out of which it dot first colon it dot second, and then I'm going to tell this join to string that the separator will be /r /n. So this actually this single line here is the opposite of this. Is the opposite of here. We converted to the pair, then to map. Again, we are converting to pairs. Then we are
joined together.
Yes, we are joining those pairs into string. We can do all these with a while loop, and but as we go on, you'll see that with Kotlin we won't see any while or for loops. We have these great functions that we can chain them and do many great things. We can map, then filter, then join, then again map, then everything is doable with these functions. So we have the response headers, and then a /r /n, of course. So the response will be something like this. Response status line /r /n. Response headers /r /n. Yes. Then comes the body. Response dot body. Okay.
The mission is complete.
No, we don't know that. We don't know that. We can test it actually. We can put it into test with the Chrome to see what will happen. Actually, let's do this. Let's run it and ask for the product list with the Chrome, not with the customer application here. Oh, we have. Yes. We have some errors here.
Constructors are not.
Because we've changed the construct. Yes, we have to send Recourse URIs. We will tackle these later. Just first, let's run it. And again, the connector. Actually, I'm just trying to make it run. These are not correct passing method here. This is the connector. Let's again send something just to make it work. Let's see the status. Yes, it needs a status. Then headers, then the body. Permission denied. It's because we were going to take the port 80 last session, I remember. Oh, we are actually running the test. We should run admin application. Okay, the admin application is running. It is actually also listening on this port 1, 2, 3, 4, 5. Let's send get product list. Let's send something else to see if it returns 404. Local host 1, 2, 3, 4, 5. For example, ABC. the Recourse URI. Let's see. 1, 2, 3, 4, 5, and let's print it. Let's print it and see if it is coming here actually. Print ln request dot method and Recourse URI. Maybe we have some error in the HTTP server because we've not tested it yet. This is the first time we are testing. So let's request again. We are not seeing anything. This means that we have some error in the HTTP server. /r/ends. It means that we don't see two consecutive /r and /ends. Let's get rid of this. And let's print ln their request and headers. 1, 2, 3, 4, 5. I'll run it again. Okay.
We have got something.
Yes, we have something. But we have something. Let's print outside to see if it breaks from the while loop, because my guess here is that it actually stuck inside the loop. Again, reload. Okay, it gets outside of the loop. We have it. Just look at here. You know, we have get, then /abc. The Recourse URI is the thing that we send after
ABC.
After the host. So the host is localhost 1, 2, 3, 4, 5. Then these are the headers. You can see the headers are actually delimited by this colon. We have these headers. Then we have, and each header has /r/n at the end. And then we have the request line with this one, and we pass it to. Maybe it's because, let's put the print here. Let's make it response string and see if we get the response string. Let's see if we are sending the response correctly. Nope. We don't have any response here. It's because of that. The callback, maybe the callback. Let me run it as debug actually. It's not coming here. Oh, it's because of read all bytes. It's because of read all bytes here. The read all bytes will actually continue until it sees a -1 in the stream, but it is not seeing any -1s. It is not seeing any -1s. Why? Because the other side has not closed the string yet, although it is not sending anything. So the trick here to actually know how much we should get out of the
timer we can.
No, not timer. Actually indicate the end of the body is the content length header. If we have any content length header in the headers, so if we say if headers dot contains key, let's see, content length. If the headers contains content length, then val content length, because the client should tell us in the headers that I'm going to, after the headers end, I'm going to send 1 megabyte of body to you. It has to tell us. So I say headers dot get content length. I ask for it, the value. Then I try to convert it to integer. And because the headers might not have the content length, I insist with this null asserted operator, 2 exclamation mark. I'm telling that it won't be null. Yes, it is absolutely, it has value. Then I convert it to an integer. So now that I have the integer, the content length, I can actually read in string dot read n bytes, not all bytes. How much? As much as content length. And then let's convert it to string as we did before. It will be the body. And I'm going to show you something here. I'm going to say body here will be string. If it has headers, content length, the body will be this, yes? If it doesn't have the content length, the body will be an empty string. Then I'm going to send the body. Yes, so far so good. But in the Kotlin, even the if statement is an expression. So it is returning some value. As you can see, it is suggesting something here. The if will return the value of the last line here, the last line. I can take out this body equals here. And I can say if it has headers, return this do everything, then return this last line. If not, return this empty string. It will actually assign it here.
Really?
So the if statement is an expression itself.
In Java, can we do that?
No. Even here with try catch, you can do this. You can say in the try, end something at the end of the try, in the catch, return something at the end line of the catch. Then, for example, return it, assign it to some value. And you can do something like this. You can make it a single line, then you can get rid of the string.
Amazing.
Yes. Okay, so let's see if it will work this time. Reload. Okay, we are getting 404, HTTP response 404, because the server doesn't have this ABC. We can actually send some static page for.
As if here we get.
Yes, we have it.
Get ABC 404.
We can return something for 404 or in static page for 404, but let's do it later. So let's send get product list. We are getting this. You can see that, and this client understands it. It stops, as you can see, it is stopping. Let me inspect it. Go to the network and go to it is I believe, let me refresh it. I want to show you the headers, the incoming and the ongoing headers here. All or get product list, yes. So actually it is the get product list is a get. It receives the status code 200. And the request headers is these. This client sends these request headers, then receives this response. The response has this body, this payload. We can also use the postman. The postman is another HTTP client. We can use the postman to show you that. I'm just using these standard HTTP clients just to show you, prove that we are following the rules of this RFC when we are writing the HTTP server. Because if we make some mistake there, these HTTP clients won't work, because they only know they can only understand the HTTP response, a standard HTTP response. Let's send, for example, local host or 127.0.0.1 and get. Let's send something like A, B, C, D to see what will happen, and not post. We can send post because in the server we are not yet deciding on the methods, we should also take these into consideration in the server side. Let's send it. We are getting 404 not found. Let's look at the headers, no cookie, no body. And now let's send, oh, sorry. I'm not given the port. It is actually connecting to my other server, to Apache server. I have this Apache server on port 80, and if we don't give the port, it will append 80. I have another server, HTTP server running on my machine. Let's send the port 12345. And it is not connecting, and why? Why is that? 12345 should connect.
This is 1234 or 12345?
No, 12345. Let's cancel and ask for get product list. Maybe HTTP. It is HTTP. Nothing wrong there. And also this 127001 means localhost. Again, no. Localhost means the loopback address. I think we have an error here, and that error is because we are not sending back the response correctly, and that is, you know why? Because we have to actually include an a response header indicating the length. So I have to append also to the headers response dot headers. Let's add another one to the headers here. So response headers ending with / or /n. At the end, I add another one. Content length. I as server has the responsibility to put these general headers, content length, you know, like and then let's make it a var, not val this time because I'm changing it. The content length is, we have the body, yes? We can say response dot body dot size or length for the moment. But if body is for example Persian characters, the length won't work because it is more than that. So I'm appending this content length. Let's see if this will work this time. Oh, and I have to put a / r / n at the end. So I appended another header to the headers that their server gives. So now again, if I send it again, nope, I'm not receiving any response. But this is, I don't know why this one is working and the other one doesn't.
That's not because of get.
No. Because we are not deciding on the get or post, or even the 404 is not working. Localhost 12345. Okay. Maybe I'll try to solve it off the camera, and the next session we will continue from here, solving this problem, and then we will refactor this connector to HTTP connector, because this is, and then the customer can send HTTP requests to this server, and from there we will continue adding features, because then we have completed the HTTP server and the client. Okay,
Very good.
I know this is enough.
Thank you very much.
It was a long session. Yes, thank you.
Thank you for watching and supporting us. Take
Thank
care.
you. Bye.
Bye-bye.